We'll finish section 3.4 with our last piecewise defined function. So again, we've got a function defined in pieces. So let's find f of -2. When x is -2, what does it tell us? Which one of these intervals are we in? We would be in this one, right? Between -3 and 1. So we would say -2 times -2 plus 1. That would be 4 plus 1, or 5. F of 1. When x is 1, we're told that y is 2. And f of 2, when x is greater than 1, we square it. All right, let's look at the domain. Starting as low as we can, how low does it go? Well, it goes all the way to -3, and that's where as low as it goes, and it includes -3. And then we go from -3 almost to 1, then we get to 1, and then we go all the way to positive infinity. Greater than 1, positive infinity. Okay, this time they're asking us to find intercepts. Okay, this is kind of an interesting thing to do for intercepts, because we want to, of course, to find the x-intercepts, you let y, which is f of x, equal 0, right? So if I say 0 equals -2x plus 1, and solve this, -1 equals -2x, so x equals 1/2. Here's what I have to do. I have to ask myself, well, if x is 1/2, can I use this function? You know, it has to fit. So I'm saying when x is 1/2, I would be using this function. Would I use this function if x is 1/2? Well, yes, because 1/2 is less than 1 and greater than or equal to -3. So that does give me one x-intercept. And it is x is 1/2, y is 0. Okay, so we know this point, 1, 2, that's not an intercept. And if we set this one equal to 0, 0 equals x squared, then we get x is 0, but if x is 0, we're not using this function. So that's the only x-intercept. I'm going to come over here to find the y-intercept, if there is one. How do we do that? We let x equal 0. Now, that tells us which one of these to use. Which one of these three do we use if x is 0? Well, we use the first one, right? Because 0 is less than 1 and greater than or equal to -3. So f of 0 equals -2 times 0 plus 1, or 1. So we have a y-intercept at 0, 1. So that's the other part of part C. Didn't have enough room. Okay, let's graph this thing. Again, we need to get a few points. When x is between -3, so it gets as low as -3, -2, -1, 0, okay, it would all be in that interval. If I put -3 in here, -2 times -3 is +6, plus 1 is 7. -2 times -2 is +4, plus 1 is 5. -2 times -1 is +2, plus 1 is 3. And -2 times 0 plus 1 would be 1. Okay, so that's what this interval gives us. Then we also know this point, x is 1, y is 2, is on our graph. X is 1, y is 2. And when we have positive or greater than 1 values for x, then we use the x squared. So we'd have, let's see what happens at 1. We can't use 1, but if we put in 1, we get 1, right? But that's a hole right there because we can't allow it to be 1. But we're going to get awfully close to it. So I kind of circle it and remind myself it doesn't quite get there, but it gets close. When we put in 2, we get 4. 3 gives us 9, right? So let's see what we have. -3, +7. And it terminates there, right? We cannot go beyond -3. -2, +5. -1, +3, 0, 1. Okay, and what would happen if we can't use 1 here, but like I said, we can find out how close it gets. If I put in 1, -2 times 1 would be -2, plus 1 would be -1. So kind of like to circle that and say, well, if I could get to 1, x is 1, I would be at -1, but I can't get there, but I'm going to get as close as possible, right? Because it says it has to be less than 1, but it doesn't say less than 1 means 0. Less than 1 can be 0.9999, right? All right, and again, it terminates there. There's no arrow because it says greater than or equal to -3. Okay, then we get close to here, then we pop up and fill in that hole here, and then we have a hole at 1, 1, and 2, 1, 2, 3, 4, and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that one does continue. This is our quadratic that starts here at 0, 0, but we can't start there because we have to be greater than 1, but we know it does something like this. And it does continue on. So now we can determine the range. What's the lowest possible value for y? Well, it gets close to -1, but it doesn't get there. And then there's no break in here as we go up to positive infinity. Is this one continuous on its domain? The domains from -3 to infinity, do we ever not have a break in here where we're not using our x values? No. So this is continuous on its domain.